Hello class, Mrs. O'Toole isn't here today, so I'm going to be filling in. You guys might know me from down the hall. My name is Mr. Culus. I'm a math teacher here as well. It's like Ethan is here, Carson is here. No Keegan today? Alright class, so today we're going to be learning about a few calculus concepts.
Hey, Mr. Culus, I'm Tommy. Why do we need all this stuff anyways?
Well, I'm glad you asked, Tommy. It's because calculus is everywhere! And you wouldn't want to get sent to math jail, would you? How about we start with something easy? Now class, watch as the sand bounces up and down in the water. If we were to plot the sand's y position as a function of time, you would see it looks a lot like a cosine graph. And just like other differentiable graphs...
Guys, quiet down back there.
Thank you. As I was saying, like other differentiable graphs... Sam, do you have something that you would like to share with the whole class?
Calculus is so stupid. Why do we need to know?
Like other differentiable graphs, you can take the derivative of sine and cosine graphs. When we do this, you'll notice that the derivative of a cosine graph is just a negative sine graph. Sine and cosine have this special relationship where when you take the derivative of a sine, it's a cosine, and when you take the derivative of a cosine, it's a negative sine, and so on and so forth. This also works backwards with integrals. Our second topic is going to be vectors. For example, the elytra wings. This is my assistant, Dr. Grithm. While gliding down at a 40-degree angle, Dr. Grithm here has a velocity of 20 meters per second. We can use right triangles to figure out how fast he's going down, which would be y, and across, which would be x. If you set up a sine equation as sine of negative 40 degrees equals y over 20, you'll be able to find the y value. You can also do the same thing with a cosine graph for the x value, with the equation of cosine of negative 40 degrees equals x over 20. Remember, when setting up, you have to make the angle negative because he's flying downward. Now, if you set up all the equations correctly, you should get x equals 14.321 meters per second and y equals negative 12.856 meters per second. Hey Al.
Hey, Cal.
The last topic we're going to talk about today is geometric series using cake. Everybody loves cake. We'll demonstrate a basic geometric series using slices of cake. If you were to take a cake and remove 1/8 of it an infinite amount of times, you would have a series equation that would be 7/8 to the nth power. The question is, if you kept doing this to a full cake, how many cakes would the series converge to? To find this, you would use a over 1 minus r. A is the coefficient, which in this case is just 1, and r is your ratio, which is 7/8. Even though you're taking an infinite amount of slices out of it, it would still come out to be 8 full cakes. Alright guys, we're almost to the end of class. Tomorrow, make sure you tell Mrs. O'Toole about how much you learned about the importance of calculus. Now, you guys enjoy the rest of your day.